Hello, and welcome back to our series on synthesis for aromatics using EAS reactions. That's electrophilic aromatic substitutions. So this is actually the second video of the series. There's only two. And we already talked about some of the things, so I'll just review what we talked about before just really quickly, and we'll move on to the new reactions so we can know about ortho and para substitutions instead of just meta, which is what we talked about previously. So let's get into it. In the last video, I talked about which reactions you would need for this section of synthesis, so you can pause the video and look at that again, but let's go ahead and move forward. And similarly, we talked about the general strategy that we're going to use, so if that doesn't look familiar, go back to the other video and look over that again, but we are going to use that same strategy again. Specifically in this section, we are going to talk about protecting groups and masking groups, so we'll learn more about that. Just for continuity, I did want to mention that the first example we looked at, we talked about functional group transformations and how we can use them specifically in this case to get meta substitution. So we talked about that and then we listed all the possible reactions for this specific example. So we're going to use a similar strategy, but now we're going to talk about some other substitutions that we can get. So without further ado, let's get started on some new examples. So in this example, we're going to use something that's called a masking group to get a specific isomer. So if we apply the strategy that we're using, the first thing we want to do is figure out if the product is ortho, meta, or para. So what do you see? Right, so it says this one's ortho and that it's the only isomer, so that's going to be important. That's why we have to use a different strategy. Otherwise, normally we would get ortho and para no matter which director we use to get ortho. So now let's look and see what kind of directors we already have that we're going to be able to add later. So let's take a look. So the first one is the OH, so we'll look at that. So what kind of director is an OH? Right, it's ortho para, right? So that's a good sign. And then what about the nitro group? What kind of director is that? Right, that's a meta director, so we don't want to put that one on first. So like if we start with benzene, that would not be the first reaction we want to do. Of course, in this reaction, we're starting with the OH already on there, so we know that that's going to have to be the first thing on there. So that's helpful. All right, so now we need to figure out what reactions we can use to make the product, so that's the next step we're going to do. So when we do that, what new things we're adding are just going to be the nitro group, right? So what is the reaction that we can do to get a nitro group? Right, it's just going to be this one. All right, so we have that reaction, and so far that's the only reaction we have. So looking at that, we already know that nitro is a meta director because it's actually in the final product, so we don't have to worry about that part. So then the next question we're going to say is, can we have a masking or protecting group? So anytime you have an ortho and para, you're going to have either a masking or a protecting group. So this one's going to be the masking group. So what the masking group does is it covers the spots that you don't want to react, and then later you can take it off. So we need a reaction that will react on the benzene ring directly and cover a spot, and that we will be able to take off later. So thinking back, what kind of reaction did we learn that can do that? Right, it's going to be a sulfonation. If we put that sulfate group on there, we can take it off later. So let's write down what those reactions are. So to put the sulfonate on, what is that reaction? Right, it's this. And then to take it off, what reaction? Right, so it's like the reverse reaction. Remember we said there was a reversible reaction? So that's the reversed reaction. So we're definitely going to use those, and then we'll just see how that works. So for this one, we don't need any other reactions, so we'll just go ahead and label these. And now let's figure out the order. So obviously if we don't put the masking group on, we know that the nitrate is going to go ortho and para, so we don't want to do that. So the first step would obviously be put the masking group on. So let's do that first. And then once we get the masking group on there, it's going to look like this. So I'm going to go ahead and draw the product. So right now you're probably wondering why we put two of those groups on there and not just one. So remember we said that some of the groups are activating and some of the groups are deactivating for a benzene ring. An OH is very strong activator, so that means it's going to make it really nucleophilic and want to add a bunch of stuff. So in this case, we just find experimentally that if you have a phenol, which is what that is, that it will add the sulfonate twice. So the sulfonate, the first one deactivates it a little bit, the second one deactivates it again and keeps it from reacting a third time, so it only reacts twice. Other groups added to an OH might be different amount. So for example, if you tried to add a bromine, it can brominate at all three spots because it's not as deactivating. But for this example, we're just going to do this one, which we know will add twice. All right, so we got those two groups covered, but notice now we have this hole open on the ortho side, and that's where we want to put something. So that's going to be really cool. So let's go ahead and do that. So now we can add our group, which is reaction A. So if we do that, we'll go ahead and draw the product because we know what it's going to be. There's no question this time. So it looks like this, right? And then the last step we want to do is probably going to be the one left over, so that's going to be C. So we're going to take that group off. So let's go ahead and draw that in. All right, so just to recap, what we did is we put our masking group on, that's the green reaction, and then we put our group that we wanted on, and then we took our masking group off, which is the blue reaction. Now, a couple of things to notice is we said that this works with OH. Could it work with other groups? And the answer is yes, but only a few. So we know it has to be something that's very activating. So another activating group we have, for example, is NH2, but we find it doesn't work with NH2, and I'll show you why. So if we react this with an NH2, an aniline in this case, if we react this reaction, the first product we're going to get is not going to be sulfonation. Instead, you're going to get an acid-base reaction, right? Because that's already basic and we're adding a strong acid. So you get this product. So looking at this product, what kind of director do you think it's going to be? It's got a positive charge. Right, so if it's got a positive charge, that means it's going to be a meta-director. Things with positives and partial positives are meta-directors. So we don't want to use a strong acid with any of the NH2 groups because they'll always get protonated, and then that's going to change the directing effect. And also it changes it to a deactivator, right? Because now we've got that positive charge there. So generally you don't want to have acids with that. Also, I want to point out that we're never going to use a masking group to try to get something to be in a meta position. It just doesn't work that way. Even if we were to somehow cover up all three of the spots, the orthos, both orthos and the para, it would still not want to go there because then it would be so deactivated, it wouldn't be reactive enough to go there. So you're never going to get a meta product using a masking group, so don't try that. So just to summarize, the masking group is always going to be to make ortho only and no other kind of substitution. And we're going to be able to start with either an OH on the benzene ring or this thing here with a nitrogen with the thing on it, which we'll talk about later. Okay, those are the only two groups that we're really going to use with the masking group. All right? Okay, so let's go to the next type, which is para. That's the only one we have left that we haven't done. All right, so let's look at this last example where we'll show one more strategy. So in this case, we want to do the same thing, right? We're going to start off and identify what type of substitution. So is this ortho, meta, or para? Right, so this is para. So then the next thing we want to do is figure out what directors we have. So up here we have the NH2. The NH2 is what kind of director? Right, it's an ortho-para director. And then what do we have on the bottom is a Cl. So the Cl is a ortho-para director also. So that's a good sign that we're going to be able to make our product. Now if we look over here on the left, we know we already have the NH2 on there, so that's also going to help us with the order because it's already on there, right? Okay, so then the next thing we want to do is figure out what reactions we can use to add functional groups. So in this case, we can add the chlorine, right? So then what reaction can I use to make a chlorine? Right, so it's going to look like this. So that's how I'm going to add the chlorine. All right, so remember in this section, we also want to consider if we need to have a masking group or a protecting group. So obviously, based on the title of the slide, we're going to use a protecting group. So how are we going to know that we need a protecting group? So the first thing is that we know we want to make the para-only isomer, and we are going to find out that the protecting group makes that, so that's going to work out great. It's going to add some sterics to the top, and that's going to help protect the top part, basically, from this. But the actual protection that they're talking about is to protect the functionality of the NH2 group. That's where the protecting group part came from. So when you have an NH2, we said it can do an acid-base reaction, right, in the previous slide. So if we don't want it to do that, we can add the protecting group, and then it won't do the acid-base, because when you make an amide, which we'll see, that doesn't react the same because it's not as basic as an amine. The other thing is that NH2 will not just react with regular acids, it reacts with Lewis acids. So NH2 will react with the iron chloride of our chlorine reaction, and it will cause it to be ionized, and then that's going to mess up our directing effects and also make it deactivated. So basically, NH2 needs to be protected in this scenario, which is why we're going to use protecting group. Okay? So remember on our list of additional or supporting reactions, one of the things was a way to change the nitrogen, the NH2. So this is the one we're going to use now. So you start off with the aromatic NH2, and then you're going to put this carbonyl on it. And then to do that, you use the chlorine version. And then, so the thing at the bottom is triethylamine, and that's just a base that's going to help make the reaction go forward. You don't have to know the mechanism of this right now. We'll actually talk about it later, but not till future section. All right. So then obviously we want to have a way to put the protecting group on, so now we need to have a way to take the protecting group off. So the way to do that is to do the opposite reaction, which you saw on your list. So it just looks like this with sodium hydroxide and water, and then that's going to cause the carbonyl to come off. All right, so now let's check the order. So obviously we want to put our protecting group on first because otherwise it's going to go in the wrong position and not work because it's got the problem with the iron chloride. So we'll put our protecting group on first, so I'll go ahead and draw that up here. All right, and so then once our protecting group's on, we don't want to take it off until we do the reactions, right? So we'll do our reaction that we wanted, which is to add the chlorine, so that's A. And then the last thing we're going to do is obviously take it off, so then we're going to do reaction C, just like this. So those are what the product looks like. All right, so just to be clear, when we're adding the protecting group, the reason why we're getting para only is because if you look at the top, this little group that we're adding, I kind of call it the umbrella group because it looks like it's a little umbrella. So imagine that there's not only this carbon like coming up here, but there's also these little hydrogens that are helping to block the top. And remember, it's not just always going to be on the right side, it could also be on the left side because there's a rotating bond there, right? It does have some rotation around the top, so then it can be on either side. So it kind of blocks both sides. All right, so think of this as the umbrella group protecting the top, and then the bottom is open. So that's kind of what we want. And so just to summarize, if you want para only, this is the best way to get it with the protecting group, and it only works with NH2. You can use this to get another option, but you'd have to combine this and the masking group to get ortho. All right? So hopefully this makes sense. Also notice that for these were still fairly short syntheses for these examples 2 and examples 3, but you could also do masking group or protecting group and then also have some functional groups interchanging. It's just in this case we didn't have any changes to the functional groups, so it's a little bit shorter. So some of these reactions can be longer for the syntheses because we have to put these things on and take them off, and also in a convert stuff that's going to make it longer. So just keep that in mind. These were a little bit simplified examples. All right, so that's the end of our video. We've now figured out strategies to get only meta, only ortho, and only para. So with these 2 videos, hopefully you're now able to at least have strategies to work with those. So the next step is going to be to try out these different strategies on different problems, right? So make sure you check Blackboard for the activities, and definitely let me know if you have any questions. Hopefully you found this helpful, and I hope you have a great day. Bye.